Okay, guys, so continuing on with linear expressions, right? We've talked about adding them. We've talked about subtracting them. Now we're going to talk about taking them and factoring them. Okay, so if you don't quite remember what factoring is, we're going to talk a little bit about that. All right, so before we get going, though, I want to share this with you. The first word is monomial, everyone. Monomial. So if you don't have your notes, of course, out, go ahead and agree on the left, notes on the right. It has a little star by it because I'm assuming that it is not in your notes, right? Yes. Okay, that doesn't mean it's any less important because it will be in the directions. I just want to make sure you know what a monomial is. Okay? So, here's what a monomial is. All right? Your book refers to it as a number, variable, or product of a number and one or more variables. Does that sound familiar to anyone? A monomial is a term. All right? So that's what a monomial is. So as you guys get older, right, you're going to be talking about binomials and trinomials. Thinking about the prefix on those, right? Bi and tri, like bicycle, tricycle. Thinking about the meaning. What do you think that meaning is, that prefix right there? One. So that's exactly what it is, one term. Okay? So just when you come across that won't be foreign to you. Okay, you'll know what that is. All right, let's get to the rest of our words, though. The very next word is factor, everyone. Factor. So your book says this is to write a number as a product of its factors. Okay? So the definition, that is just the verb, right? And that would be the noun. All right? But it's one of those weird words where it's kind of the same word. Okay? Both forms are the same. So here's what I want you to put in your little box off to the side. This is when you sometimes write it in what's called factored form. So it's the action of writing it at times in factored form. Okay, well, you don't know what factored form is. Well, guess what? That's our next word. So factored form, everyone. Factored form. All right, so here's what factored form is. This is a monomial expressed as a product of prime numbers and variables where no variable has an exponent greater than 1. So here's what that means. If you have something like 12m, 12 would factor out to 2 times 2 times 3 times m. If this was 12m squared, it would be 2 times 2 times 3 times m, 2 m's multiplied. Okay, so that's what factored form is. How many of you guys did like prime factorization with like a factor tree in elementary school? You guys remember that? Okay, there's different ways to factor. I'm going to show you a different method I'd like you to try to use today. It's one of my favorite methods because I feel that if you do it right, that it kind of gets rid of some of the easy mistakes people make. All right, so we'll take a look at that here in a second. All right, and that is it for words. So go ahead, grab a piece of paper, flip your book over to page 318. 318. All right, name, date, period up at the top. All right, really quickly, before we start this lesson, I want to do a little activity with you guys, and it's not like a long activity, it's a very short one. You guys remember what greatest common factor is? Okay, here's what I want you to do. I want you to find the greatest common factor, okay, of 14 and 56. All right? 14 and 56. Okay, here's a twist, is I'm going to now just give you an extra 10 seconds starting right now to try to find out what that is. Go. All right, here we go. Eyes up here. Okay, I heard 7. Agree? Disagree? Okay, some agreement, some disagreements. Okay, some people looking around like they're not sure. They're looking at what the majority vote is. All right, that's not a good strategy. All right, because that's not telling me who knows what. All right, now every year I do this quick little 15 to 20 second activity, and it is always a 50-50 shot at answers. It's usually the class split in half. And by looking at us with thumbs as well as agreements, disagreements verbally, or some people looking around to see what the majority vote is, that tells me that, of course, it's probably about the same this year. It's no different. Okay? Now, what happens is what I want you guys to realize is for some of us got it right, and I'm very proud of you guys. Others of us, though, what we do is we think strictly of math facts. We think which number goes in evenly to both of those, and we think of the math facts chart. And that is a problem, because you're now a 7th grader. Not everything is math facts. There's bigger factors than math facts. Okay? So, because of that, I want you to go ahead and let's start by looking at problem number 26 on 318. Okay, it ends up being what? It starts on 318. I think 26 specifically goes over to 319. Okay, on 26 we have 54GH, and we have a comma, and then we have another monomial. It's 72G. Okay, so we have two monomials, and the directions say find the greatest common factor of each pair of monomials. Okay, so here we go. Here's what we're going to do today. Step 1 is I want you to take the numbers. Sometimes they might be constants, meaning numbers by themselves, right, with no variable. Sometimes they're coefficients. And what I want you to do is I want you to factor them. Now, here's what I want you to do today. I want you to try out my way of factoring. Some of you guys probably have already seen this way, and maybe it's your favorite way. That's perfect. Some of you might be out of your comfort zone a little bit. Okay, but here's what I want you to do. I want you to use a factoring T-chart. Okay? Now, here's what a factoring T-chart is. Let's start with 54. Now, the nice part about a factoring T-chart, there's a couple little things. Now, if you do it according to how I'm teaching you, you will not miss out on any factors. Okay? Some of the other ways that people factor, sometimes they'll miss out on factors. Okay? If you use a T-chart correctly, it's very hard to miss out on a factor. So here's what you do. You start with the smallest number there is on the number line besides 0, right? The smallest valued number, and that is 1. Okay? You always start off with 1 because we always know that's a factor of every number, because 1 times 54 is always the case with any number. Okay? Now, we go to the next smallest number, which is 2. 2 can go into this because 2 goes into any even number. Now the question is how many times? And this is the spot where you can actually punch it into your calculator. It's 27. Now, 3. Listen, does anyone know the rule to see if something's divisible by 3? Do you know the little trick, Isaiah? You add the digits together. In this case, the two of them. 5 plus 4 is 9. Can 3 go into 9? So 3 can go into 54. Okay? So yeah, 54 divided by 3 is 18. Okay? Now, the main rule for seeing if something's divisible by 4 is seeing if the last two digits are divisible by 4. Well, that helps you if it's a 5 or 6 digit huge number, right? Just look at the last two digits. Well, the problem is that is our whole number on this one. Okay, so that's not good. Here's another way that you can tell, some of us can tell if if you can divide it by 4 is split the number in half twice. Once you split it in half the first time, if it's an even number, that means you could split it in half again evenly and it's divisible by 4. So I know that 54 split in half, 27. It's an odd number. It's not divisible by 4. 5, most of us know that one, ends in a 0 or 5, right? It doesn't. Okay? Can 6 go in? 6 times 9. Now we're getting into math facts, right? Some of these will be math facts. Once we get into the math fact region, and now you can start probably using math facts. So 7 times 8 is 56. That doesn't work. How about 8? 8 times 7, right? Now I'm going to go on even further, even though I don't have to. The next number is 9. Here's the neat thing about a T-chart. Once you get to the number that's already on the other side, you are done. I didn't randomly, go around with all the different numbers, just randomly try different numbers. I started with 1 and I went 1, 2, 3, 4, 5, 6, 7, 8. I just went all the way up. Once I hit that right side, that number we already have, we're done. We didn't miss out on any factor. Okay? Now doing the same thing with 72. 1 and 72. Okay? It's even, so 2 can go into it. Okay, it goes in 36 times. 7 plus 2 is 9. So 3 goes into 9, we already talked about, right? So 3 goes into 72. If you want to use your calculator, you can do that as well, right? 72 divided by 3 is 24. 72 divided by 2 is 36. That is an even number. So that means I could split it again. 4. Well, 72 divided by 4 is 18. Well, guess what you can do? You could also get that and split that in half, right? And if you can, then that's what gives you 4 times whatever is the other factor. 5 doesn't go into it. The 6 go into it. Okay, here is the strategy with 6. Check your T-chart. If 2 and 3 are both factors, then 6 is a factor. It has to pass both tests, 2 and a 3, then 6 is. 72 divided by 6 gives us 12. 7 times 10 is 70, not 72. How about 8? 8 times 9. And guess what? The next one's 9. We're done. So step 1 is we're going to factor. Okay, now step 2 is find the GCF off of this. So we have a lot of common factors, right? 2 and 3. 6 even, but look it, we also have 9, 18, and there's nothing else, so 18 is our greatest common factor. Now, we're not done. Step 3. Remember, a factor is anything that's multiplied together like that to come out with your product, right? Any broken down in what we're used to as in numbers that are broken down in factored form. However, they all have this in common, right? But if you take a look, the whole idea of having it in common, this is a little different, but you also want to see, do they have a variable in common? A common variable? Look over here, do we? G. And that, ladies and gentlemen, is also a common factor. And for this section, we're done. 18G, okay, is the greatest common factor of those two monomials. Okay, questions? Okay, listen, I'm just going to alter this to answer that question. So this is it. That's a question. That's the answer. But let's say that you had 54H and 72G. We still found that 18 was the numerical common factor, greatest common factor, right? Do they have a variable in common? No. So it would just be 18. Okay. That's a good question. All right, other questions? All right, I want you guys to try this one out here. Problem 24. Problem 24. How many of you need more time? Okay. Okay, anyone still working? All right, 30 seconds. Go ahead and turn to your neighbor, share your answer. Go.
Yeah, I got 16.
All right, let's check this out. Here we go. All right, answer seat 17.
Wow, that's the first.
I'm glad you're excited.
I got 16.
16. All right, just 16.
Just 16.
Agree, disagree. All right, we have a lot more agreements on that. Let's check it out. Here we go. 24, 32a. And the other monomial is 48b. So yeah, building your T-chart, right? 32 is 1 and 32. 2 and 16. Not 3, right? 4 and 8. Not 5. Not 6, since 3 isn't a factor. Not 7. 8 is already there. Oops, sorry, I probably should have boxed that in there. 48. 1 and 48. 2 and 24. Okay. 8 plus 4 is 12, so 3 can certainly go into it. How many times, guys? 16 times. 4 and 12. All right, because I could split it in half twice. 5 cannot. 6 Yep. 7 times 7 is 49. 8 is our next one, but there it is. And out of these, greatest common factor is 16. However, right, we always have to check those variables. We talked about that earlier, right, in the importance of variables. A, B, nothing in common. So that is, of course, why it's only 16. So good job, ladies and gentlemen. All right, questions on that one? Anyone that didn't have that? Didn't seem like very many of you were wrong on that. All right, here we go. Let's go ahead and let's take a look at problem number 32. Okay, problem number 32. I want to introduce this to you just by you watching. This is one of the I do moments. So go ahead and put your pencil down. I just want you to observe, and then we'll write the steps here in a second. So we have 10x minus 35. Okay, now our directions say factor each expression. The expression cannot be factored. Right cannot be factored. It says use algebra tiles if needed, but that's not what we're doing. So right cannot be factored if it can't be factored. So here we go. Well, the very first thing we're going to do is we're going to view these two terms like monomials, separate monomials. Now I know that it's an expression, right? But it's a linear expression, but I'm going to view it as two different monomials, as if there was a comma here, kind of like it is up here. Okay? Then the next thing I'm going to do is I'm going to find out my greatest common factor for each number. So, or I could say for each term. So 10 is 1 and 10, 2 and 5, all right? And that's it. Just running that through my head. Okay? Negative 35, I'm going to just focus on the positive for right now. 35 is 1 and 35. Okay, 2 can't go into it, right? 5 plus 3 is 8, so 3 can't go into it. 4 times 9 is 36. 5 can, though, 7 times. 6 cannot, but 7 can, but we already have it. If I take a look here, it ends up just being 5 is our GCF. So what I'm going to then do is this. I'm going to take my GCF. It's a little different than before. This was just a warm-up, basically, to how to find a GCF out of two terms. I'm going to take my GCF here, and I'm going to push it over to the left. What I'm then going to do is I'm going to write parentheses, because I just factored out a 5 out of this expression. What goes in the parentheses is what's left over. And what's left over you can think of as we're dividing. So in this case, the 10 divided by 5. If you want to, all you have to do is look at your T-chart. That's another reason why a T-chart's good. What's left over is what's here, 2. But don't forget, we have an x left over because we didn't factor it out. It's 2x. In this case, the 35, take a look. It's a minus, and look what's left. 1. And that is our factored answer. Now, before I let you guys copy this down, I want to ask you something. If I was just to give you that as a problem, how would you simplify that? Which scale would you use to simplify that? 5 times distributive property. Ladies and gentlemen, you can think of this lesson as the inverse to distributive property. It's like they are giving us the answer, and we have to then turn around and factor it to get the distributive property problem. Okay, that's basically what we're doing. Okay, before we ask questions, we're going to do one more, and we're going to do it together. We're going to write steps. But what I want you to do right now is I'll give you about 20 seconds. Just copy this down, because that is part of your homework, right? Yeah, so go ahead and copy that down really quickly, and then we'll do another one together this time, writing steps. Sorry, guys. Listen carefully. Really, really quickly. I'm just looking at my problem. I'm going, oh, wait a second. All right. Yeah, sorry. I was looking at 35. That's our number, but I should be looking at what we factored out, right? Sorry if I confused anybody. We factored out a 5. So how we factored out a 5 here, I looked at the 2. We factored out a 5, and I have a 7 left over, right? Sorry. I have a 7. Okay. Now let's go ahead and let's do this one together. I promise I won't make a silly mistake like that again. All right, let's go ahead step by step here. All right, page 318, or ends up being on 319, right? Problem 38 is 30x minus 40. All right, here we go. Step 1. Let's find the GCF. So there is no common variable, right? So finding the GCF, I'm pretty sure it's 10, but I want to make sure. So here we go. 1 and 30, 2 and 15, 3 and 10. Okay, 4, well, splitting that in half is 15. It's not divisible by 4. Okay, 5 and 6. Okay, and obviously we would loop around, so we're done. 40 is 1 and 40. 2 and 20. Okay, 3 times 13 is 39, so but not 40. 4 and 10. 5 and 8. 6 times 7, right, would be 42, and then 7 times 6 is 42. I've already looped around, so that's it. Greatest common factor is exactly what I thought. It's 10. Okay? So, step 2, write down your greatest common factor. Step 3, write down your parentheses. Step 4, put what's left over. And again, remember, it's basically division. So once I divide out of 10, the 30x obviously is 3. Don't forget your x. Okay? Take out the 10 here. What's left over is a 4. So it is minus 4. And there is our answer. All right. Any questions on that problem? Okay. Okay, here we go. I want you guys to try out problem number 36. 36. Go. Bless you.
Thank you.
Okay. Anyone still needing more time on that? Okay, a few more seconds, and I'll let you guys share. If you guys get done, again, remember, work on some of those in that same section there. Okay. All right, 30 seconds. Turn to your neighbor and share. Go.
I got 6 parentheses 2.
I got 6 parentheses 2 plus 5x.
Plus 5x. You didn't see it.
All right, here we go. What are some answers out there for number 36, seat 22?
6 times 2 plus 5x.
You bet? Agree, disagree. What do you guys have? Okay. Majority of agreements. Anyone have something else they'd like to share that? Okay, well, let's check it out. Here we go. All right, very first thing, right, is finding our GCF, our greatest common factor. So we have 12 and 30. So 1 and 12, 2 and 6, 3 and 4, and then obviously 4 and 3, so I'm done there. 1 and 30, 2 and 15, 3 and 10, not 4, but 5, yes, 5 and 6, and then obviously we go to the other side. Taking a look, our GCF is not 12, but it is 6. So I go ahead and write it down. All right, use blue pen here. 6 parentheses. So what is left? Well, right here, it is the 2. Right here is or plus, I should say, 5. Don't forget your x. And there we go. All right, questions? All right, here we go. Let's, by the way, just want to let you realize that if you do one of these and you find you factor everything and the greatest common factor is 1, that's when you write cannot be factored. Okay? So if you do the whole t-chart and the greatest common factor is 1, that means it can be factored. Right? Because if we have 12 plus 30x, if you factor out a 1, here's what it looks like. Ta-da! Okay, that's just a waste of time. All right? So you're only factoring out a 1. It doesn't change anything. Okay? So that's when you write cannot be factored. Any questions on that one? Okay, here we go. Let's try problem 41. 41. Okay, this looks a little different. All right. I'm actually going to flip this over because we're running out of room here. So let's try 41. On 41 in your book, it looks like this. You actually have a rectangle. And in that rectangle, it's broken up into 2 sections. You have this section, which is 5x. And you have this section, which is represented by 20. Now, here's what it says. Write an expression in factored form to represent the total area of each rectangle. So listen carefully. Here's what you're going to do. I'm just showing you, it's the exact same steps as before. So what I mean by that is this. This is like them giving you 5x plus 20. Remember, if this was a rectangle and it wants to know the area, this part is 5x, this part's 20. To find the total area is just 5x plus 20. It's both of them put together, which would be your total area, right? So that's why I have the plus sign here. Now listen, all they're asking you to do is factor that. So it's exactly what we've been doing, but I just want to show you that it looks a little differently. So all you would do is you do step 1, which is find your greatest common factor. Now, here's a big one you guys want to listen to. When the smallest, or I'm sorry, well, yeah, out of the 2 numbers, when the smallest one goes into the larger one evenly, that is your greatest common factor, right? It's kind of like when you're doing, when you're dealing with fractions and you're trying to find a common denominator. That's the same thing. When the smaller one goes into the larger one, right, you would use the big one here. Same kind of idea. this is your greatest common factor. So here's what I'm saying. On tonight's homework, if the small one goes into the big one, you don't have to build a t-chart because it's right there. That's it. So what I'm going to do is I'm going to write down a 5 on the left side. Okay. And on the top, I'm putting what's left over, which is here, it would be x. And what's 20 divided by 5, guys? 4. This is a positive 4. Now, however, they want you to write it like we have been, like a distributive property problem. So that's the proper way to write it. So all you're doing is you're putting that in the front and your x plus 4 inside your parentheses. Bless you. Now, some people, of course, will do this because it's talking about the area of a rectangle. They would put units squared because area is always squared. Okay, but that's how you would write your answer. You will have to put square units when we get into geometry and some other things, but because of the expression, I won't be too picky on that this time around. Okay, that's what the answer key will say though when we correct it. So guys, all I wanted to do is show you, this is exactly the same problem. It's just it looks a little different, but it's exactly the same thing. Okay, any questions on that? I'm going to have you try one of these. Any questions? All right, go ahead and try out problem 42. Go. All right, anyone need more time? Okay, 30 seconds. Go ahead and turn to your neighbor and share.
What'd you get?
Well, I didn't try to get
I got 7x plus 7.
It doesn't matter.
Okay, now this has a little twist, and I saw some people talking about it. Okay, but if you are just trying to fly right through it, this is where you'll make a mistake. If you follow the steps and do exactly what I've been telling you the whole lesson, you won't make a mistake. So here we go. First of all, that goes into that, right? That means that that smaller number is our greatest common factor. They don't have a variable in common, so it's just a 7 on the outside. So remember I said what's left over. Many people would go, oh, 0. But remember, this is all about multiplication and division. 7 times 0 is not 7. It's 7 times 1. So that's the factor left over. When I divide 49 by 7, I get a positive 7. But of course, don't forget your x. So when you were to write this, you would have 7 times, and then what's on top is 1 plus 7x. So just be very careful, especially with that first part. That's where some people make the mistake. All right, questions about 42? So yes, you can put units squared afterwards. And that again is, yeah, that's what the key will say. Okay. Now I want to do one more with you guys. Okay, and this is a little bit more challenging. All right, but you don't have very many of these. And let's go ahead and take a look at problem number 48 down at the bottom of that page. This is exactly the same problem. However, of course, this is where the advanced math comes in. All right, so what we have for 48 is this. We have 2/3 x plus 6. Now listen, you might say, Mr. Wilkins, first of all, I can't do a t-chart for greatest common factor. You're absolutely right. On this particular one, here's all you have to do. All right. Step one is what they want you to do is they want you to factor out the what's called the rational number coefficient, which is just the fraction. Okay. So here's what you're going to do. You're going to take that number, and that's what you're factoring out, 2/3. Okay. Step two is write your parentheses, just like we've been doing. Now, if we have, and of course, step three is what's left over, right? But this is the main part here, division. We have 2/3 times x. If I divide by 2/3, what do we have in that first term? X. 2/3 times x is 2/3 x. I could check it that way. Now, here's this next part. See the division sign? That's what we're doing. 6 divided by 2/3. So when you go over here, you're going to have a little extra work, and this is the main part of your work right here. So just remember, this is 6/1 divided by 2/3, which is 6/1 times 3/2. Cross reduce, and we get 9/1, which is what? 9. Don't forget, bring it as a positive 9, and there's our answer. Okay. All right, guys. Factoring linear expression.